Bitcoin's 6 years old, and depending on how old you are, that either seems like a very long time ago because you're in high school or junior high, because you remember Barack Obama had just been inaugurated president when Bitcoin was launched. You might remember Lady Gaga was just launching it really big. She had her first big hit in like late 2008 and her first big album in 2009. But of course, we all think, Bitcoin is the most important thing that happened 6 years ago. One of the things I think Satoshi didn't know is, would it bootstrap? If you go back and you look at his early writings, he really wasn't sure that Bitcoin would go anywhere. Nobody really knew if Bitcoin would go anywhere, and that's why for the first year and a bit of Bitcoin's life, it was worth absolutely nothing. You could not find somebody to buy your Bitcoins because there were a couple dozen people in the world who understood what Satoshi had done. I think another thing Satoshi didn't know is, was it legal? Would he be thrown in jail for creating this new way of doing money? Back when I got started in May of 2010, I didn't know if Bitcoin was legal, and I was actually kind of worried about, would I get thrown in jail by contributing to this open source software project? We didn't know back then. Today it's actually much, much better. As Patrick said, I think last year a lot of regulations kind of got worked out, and regulators started to come to terms with Bitcoin 5 years after it had been invented, but 5 years for a regulator isn't really that long, I guess. I took this from the Securities and Exchange Commission website, where they have an investor alert about Ponzi schemes using virtual currencies. And the important word there is using. They don't say that virtual currencies are Ponzi schemes. They're just warning you that there are Ponzi schemes that use virtual currencies. And that's a really good thing, and that's a really good result. And 5 years ago, if you'd asked me, I would not have been certain that that would be the result that regulators would come to. Something else Satoshi, I think, didn't know is just how annoying people are on the internet. He probably knew this, but I don't think he'd really internalized it. I kind of got the feeling that he'd never worked on a project and put it out there and then let people attack it. And boy, oh boy, once people learned about Bitcoin, did they ever attack it? My first probably year being involved with Bitcoin was one crisis after another of, holy crap, somebody just reported something privately to Satoshi and we have to get a release out in the next day to fix it. And, please be quiet about exactly what I'm fixing, Gavin, because we don't want people to exploit it before everybody's had a chance to upgrade. There were a few incidents like that in Bitcoin's early life. One of the interesting early incidents is this problem called penny flooding, where if you have 2 instances of Bitcoin running, in the early days, you could create Bitcoin transactions for free, send them back and forth to yourself all day long, just because you can. And because people are annoying on the internet, people did. So this is a graph of transaction volume over time, and you see these spikes in 2010 as these penny flooders decided it would be fun to just flood the Bitcoin network with a bunch of pay-to-self transactions. It doesn't cost me anything. I have the technical ability to do it. Yeah, it screws up everybody else and bloats the blockchain, but what the hell? I'm an annoying person on the internet, and so I think I will do this. This is actually a big problem, and Satoshi didn't know how to solve it. And actually, my proudest moment in Bitcoin is this email I got from Satoshi, which says, "You might be onto something, though. If transaction priority is graded based on size and age of dependencies, people who turn their money over less frequently would have priority. Priority could be the total age times size of the dependencies. That's the total value over time that you've waited before using the money. You may have finally solved one of the most challenging problems." that gave me warm fuzzies. It's like, wow, cool. Finally, I did something that Satoshi really appreciated. He wasn't the kind of guy or girl or people who was really warm and fuzzy. It was always very businesslike. So to actually get confirmation that I came up with this idea and it was something that Satoshi didn't think of, and it's a good idea, was great. Today, this is known as proof of stake. Right? You have some Bitcoins in the system that haven't been spent. That is your stake. Bitcoin Core uses proof of stake to prioritize free transactions. Proof of stake actually works pretty well for that. Proof of stake is a form of value. And if you really start thinking deeply about kind of why Bitcoin works, Bitcoin works because scarcity plus utility equals value. If you have something that's scarce, and if you have something that's useful, then that something will be more valuable than something that's either less scarce or less useful. And there's all sorts of, if you think about the Mona Lisa, it's very scarce. There's only one of them. People value it because it's pretty to look at, I suppose. I've never been a huge fan, but whatever. And so, that's kind of one end of the spectrum of it's incredibly valuable because it's incredibly scarce and people do have some utility of looking at it. On the other end, fresh water is certainly useful, right? But it's not very scarce, so the value is not that high. In the Bitcoin system, Bitcoins themselves are the primary scarce resource. But there are other scarce resources in the Bitcoin system that you can think about. And so in the case of penny flooding and free transactions, where we don't want to use transaction fees, we use the scarce resource of basically unspent Bitcoins. Right? So Bitcoins that I've received that I haven't spent in a while. The longer I haven't spent them, the more valuable they become for this particular purpose, for the particular purpose of limiting the flow of free transactions so that you can't just send yourself transactions all day long and flood the network. I mean, our primary resource for controlling transaction throughput is transaction fees, right? That's directly spending some Bitcoin to get a transaction confirmed. And we're using this other scarce resource to make free transactions work. If you think about it, I wonder if there are other uses for old, unspent Bitcoins. I think this is an area that's actually pretty much unexplored. We might be able to leverage them for more denial of service attack prevention on the Bitcoin network. You could imagine before you're able to join the network, you have to prove that you have some unspent Bitcoins. You don't have to spend them. You just have to prove that they're kind of sitting there, kind of as a security deposit. The proof of stake folks think it might be a good idea to use this as for determining the best chain, to get consensus on kind of what the ledger history is. So far, we're pretty sure that's a really bad idea. When I say we, I mean the people who hang out in the Bitcoin Wizards IRC chat channel. It looks like theoretically, as long as everything's on the chain and you're looking at chain history to determine what should be the best chain, bad things will happen. We have a really good anchor in Bitcoin with our proof of work, which proves that some real world thing happened, and which gives you a real world cost that kind of gets injected into the system magically via this proof of work. If you think about identity, maybe unspent transaction outputs could be used as kind of an identity anchor, right? If I put up some sort of deposit of a Bitcoin or two, and that is my persistent identity, and my identity goes away if I spend those Bitcoins, maybe. Maybe we could use them for other systems. Other systems typically have a problem, with essentially, the equivalent of penny flooding, right? If you think of any sort of storage system, if you want the storage to be free, then people will abuse it. People will just store random data there because they can. But you could imagine using unspent transaction outputs as kind of a token used to gate access to some other resource. You can also use bitcoins, obviously, to pay for it. But sometimes you don't actually care about people paying for the resource. You just want to prevent bad people from abusing the resource. Also note that spent transaction outputs are not a scarce resource, but they can be useful for things like timestamping. So you have to be careful. The like going from spent to unspent. If you start to think about how I would use an unspent transaction output as kind of a token or a ticket to get into a system, you have to really be really careful about exactly when was it unspent and when will it become spent, and kind of that spent unspent edge is where all of the tricky engineering comes in. Satoshi is often called a cryptographer, and did Satoshi really know a lot of cryptography? Was he a cryptographer? And I don't think he was. There's actually very little cryptography in Bitcoin. We've got elliptic curve keys, we've got ECDSA signatures, and we've got cryptographic hashes, and that's pretty much it. There's a whole lot else going on in cryptography. Even the way Satoshi used OpenSSL is kind of naive. He used it as kind of just somebody who kind of used it at a high level, right? He didn't have any deep understanding, I don't think, of the ins and outs of OpenSSL. And I think if he was a cryptographer, he probably would. There's no mention of Schnorr or Lamport signatures in the code. And I think if Satoshi was a cryptographer, where he uses ECDSA signatures, he probably would have had a little comment saying, I didn't use Schnorr signatures because they're patented, and I didn't use Lamport signatures because they're too big, for example. And when I was putting together this talk, I actually found a quote from Satoshi that really nailed it for me, that he is not a cryptographer. Satoshi said, "Crypto may offer a way to do key blinding. I did some research and it was obscure, but there may be something there. Group signatures may be related." And now if you're a cryptographer, like key blinding and group signatures are like crypto 101. So this tells me that I don't think Satoshi was a cryptographer. He was a brilliant programmer, but he didn't have a deep understanding of like all the cutting edge crypto research that's going on. Somebody's going to be really mad at me for bashing Satoshi. Lately in the kind of Bitcoin wizard world, when we're lately, I mean the last couple of years actually, there's been a lot of thinking about the difference between transaction validity and transaction meaning. And I don't think Satoshi knew this either. And I'm going to go in pretty deep here because this is a DevCore conference and talk about really what I mean and kind of how our thinking about what's the difference between what a transaction means and what you need to actually validate a transaction to make sure it's valid. So when I say transaction validity, I mean, should this transaction be allowed into the blockchain? And the rules are actually pretty simple. The transaction has to be kind of structurally, syntactically correct, right? You can't send random garbage to a node. It has to have the valid form of a transaction. The redemption conditions for the inputs have to be correct. So this typically means the digital signatures have to actually check, right? The person who holds the public key has had to have created proper digital signatures to transfer the money to somebody else. The sum of the input amounts has to be greater than or equal to the sum of the output amounts, right? You can't create money by forming a transaction. There's actually been one point in Bitcoin's past where that was not true, and that was one of those bugs that we had to hurry and fix because there was a transaction that accidentally created something like 2 billion Bitcoins, which was bad. And the transaction inputs have to be spent only once. You can't have two transactions in the chain that spend the same Bitcoins. That's the double spending. Now I'm going to ignore Coinbase transactions, which create Bitcoins. They have a whole bunch more rules. But for ordinary transactions, these are the rules. This is what makes a transaction valid. If a transaction follows these rules, then it's valid. Transaction meaning is subtly different. Transaction meaning is like, what is this transaction all about? Who's being paid? How much are they being paid? Who authorized the payment? What is this payment for? A lot of this stuff is not in the blockchain. Some of it is, right? How much they're being paid is in there in the blockchain. You can look at a transaction and see, at least from the outputs, you know, kind of, hand wave, change addresses, mumble, coin join, multiple people. But typically you can figure out, how much was being paid in this transaction. That's transaction meaning. We're moving from, we've been moving slowly over time to separate transaction meaning from transaction validity. And I'll demonstrate that by diving really deep into kind of the core of Bitcoin Core. And the core of Bitcoin Core is transactions. Right? This is what your machine's doing when it's catching up with the blockchain. It's validating all those historical transactions. It's what it's doing when it's in a steady state, looking at transactions coming in. So Bitcoin transaction, I'll go through this quickly. Typically, a transaction is protected by a public key crypto. So the simplest possible Bitcoin transaction is, I want to send some Bitcoin to a public key that you own. Public key A, B, C, D, E, F, huge 33-byte public key. Under the covers, that transaction actually looks like the public push the public key onto this execution stack and then execute the checksig opcode. Right? So at the core, way underneath, Bitcoin has this little scripting system that decides whether or not transactions are valid. And it looks like forth. If you've dived into Bitcoin transactions, this looks familiar. If you haven't, you're probably scratching your head saying, what the heck? But basically what you have to know is there's a script pub key that I pay to that says, check the signature with this public key. The spending transaction then has something called the script sig, which gives the signature. And so simplest possible Bitcoin transaction is a 70-byte signature, and then a 33-byte public key, and the checksig opcode, which takes the signature and public key and makes sure everything matches with the transaction that is spending those Bitcoins. I always confuse myself because things are backwards. So the script pub key part of this is actually the funding transaction. So that's specified as part of the transaction that gives me Bitcoins. And the script sig is part of a separate transaction. That's the transaction when I eventually turn around and spend those Bitcoins. So it's kind of backwards. The script pub key you can think of as happening first, and then the script sig happens when I actually want to spend them. Satoshi had an idea, which was a pretty good idea. He had the idea to move the public key into the script sig. So he has this little scripting language. And so the Bitcoin transactions you actually see on the network are all of this form: dupe hash, 20-byte hash, equal checksig. And then when you go to redeem, you actually put the signature and the public key in the script sig. And the reason he did this is because he saves a bunch of bytes, right? So Satoshi didn't know that OpenSSL can represent a public key in 33 bytes. He represented public keys in 65 bytes. And so if you have a script pub key, hang on. if you have a script pub key with a 65-byte public key and a check sig, and you can replace it with just a 20-byte hash, well, that's a 3-to-1 savings. That's a whole lot smaller amount of information that I need to give you for you to send me Bitcoins. So when you see a Bitcoin address, what you're really seeing is 25 bytes, 1-byte version, 20 bytes of that hash of the public key, and then a 4-byte checksum to make sure that if you mistype something, if you're crazy enough to actually type in Bitcoin addresses. I have done that a couple times. You don't send the Bitcoins into a black hole or to somebody you don't intend. If Satoshi had known about 33-byte compressed OpenSSL keys, I bet he wouldn't have done this. I bet you we'd just have Bitcoin addresses that were longer, and he wouldn't have bothered going from 33 bytes to 20 bytes. But I don't know. It's one of the questions I'd love to ask him. The interesting thing about this is the public key is not known until the Bitcoins are redeemed, right? All you have is the hash. So you don't actually know what the public key is. This starts moving towards this, what's the meaning of separating the meaning versus validation. We actually took this one step further with this thing called pay-to-script hash, or P2SH, or BIP16. So this is Satoshi's idea taken one further level, and even further moving the meaning of the transaction over to validation time. So the way pay-to-script hash works is instead of taking a hash of a public key, we take a hash of a transaction script, and we put that in the script pub key. So I'm basically saying, send me some Bitcoins. I'm going to give the validators the script that will validate it later. You don't need to know that right now. They'll stay locked up until I provide that script and whatever other information is needed. So when it comes time for me to spend those Bitcoins that you sent me, I'll give the serialized script of the transaction and whatever other arguments are needed to validate that. So here's a typical P2SH. The Bitcoin address starts with a 3. 3 tells you that it's a pay-to-script hash address and not a regular Bitcoin address. The script pub key just looks like this, hash some value equals. It tells you absolutely nothing about my wallet. When you send me the money, you have no idea what the conditions are for redeeming that transaction. You don't need to know, so it's a good thing that you don't know. In the redeeming transaction, for this particular transaction, this is actually the form of that transaction. It's a 2 of 3 multi-signature transaction. So I give the serialized 2, public key 1, public key 2, public key 3, 3, check multisig, and I give some signatures. And I also have to put a 0 on the stack because Satoshi didn't know that there's a bug in check multisig that one day I hope we'll be able to fix. So when I get those Bitcoins, or the person who's sending me those Bitcoins has no clue about the condition that I need to spend them. And that's great. I mean, it's none of your business how I store my Bitcoins. It's not so great that everything is revealed when I do end up spending them, right? You will find out that I was using a 2 of 3 wallet, and you will see, like, which 2 signatures match the keys, and so you might be able to start to figure out, who authorized the transaction and some other information. In the near future, script sigs will be pruned. They will be forgotten by most nodes on the network. We have a pull request right now that I think actually is just waiting for a little more testing before it will be pulled, and you will be able to run a full Bitcoin node that just forgets history, forgets old script sigs. In the future, I expect that most full nodes will not also be archive nodes. They will not store the entire history of the Bitcoin blockchain. There's really no reason to. Once a transaction is buried deep enough, you can forget about it. All you have to keep track of is the unspent transactions to validate new transactions coming in. That's on the roadmap, and that's great. And we can do that because we're separating validation and meaning, right? You can forget, once it's validated and then buried, most people can forget the meaning of that transaction. I mean, obviously the people who transacted will want to store it forever. I want to remember that I paid you 6 months ago. But the whole network doesn't have to remember that I paid you 6 months ago. It's interesting, if you think about separating validation and meaning, and you go back to the rules for validating transactions, you can start to think about, well, could we separate it even more? Like, we have this rule that the sum of the inputs has to be greater than or equal to the sum of the outputs, but do we really need that rule for validators? Or not double spending. There have been some people who have proposed, well, maybe you should allow double spends into the blockchain, and then it's just kind of up to all the wallets to figure out if they have personally been double spent or not and figure out what to do about that. And those are interesting ideas, and if you talk to cryptographers and people who are into like zero-knowledge proofs, they start to work with systems that kind of get rid of those rules. And certainly for privacy, it would be kind of nice if you couldn't figure out how much you're being paid, right? It would be nice to have that be completely opaque to anybody validating transactions. But fees screw that up, which is interesting. The system needs to know how much is being paid because transaction fees need to go to miners. And so if you think about a transaction fee is just the difference between the sum of the inputs and the sum of the outputs. Miners are allowed to take that as a transaction fee. You could think about maybe some other way of sending transaction fees, but it gets hard, right? I mean, the fees have to come from somewhere. And if you break the rules about double spending and sum of inputs and sum of outputs, it's hard to come up with a fee system that works. Incentives really matter, right? Without transaction fees, Bitcoin definitely won't work. But I want to talk about, did Satoshi know how to scale up? Don't do that. Hello? Hang on. No, I've done it.
I blame the snow. The snowstorm.
I'm sure it's totally the snowstorm interfering with something. So this was Satoshi on scaling. This is actually the second public message, I think, ever from Satoshi on the crypto mailing list, where he said a typical transaction should be about 400 bytes. Each transaction has to be broadcast twice. So let's say 1 kilobyte per transaction. Visa processed 37 billion transactions in 2008, 100 million transactions per day. That many transactions would take 100 gigabytes of bandwidth, or the size of 12 DVDs or 2 HD quality movies, or about $18 worth of bandwidth at current prices. If the network were to get that big, it would take several years, and by then, sending 2 HD movies over the internet would probably not seem like a big deal. We're there. Sending 2 HD movies over the internet really is not a big deal these days. You know, I watched a couple HD Netflix movies on snowy days when I can't go outside pretty regularly. So, you know, Satoshi was confident that Bitcoin could scale. I'm even more confident than Satoshi because there's something he didn't know. He said each transaction must be sent over the network twice. And that's not true. There's actually this really cool area of computer science research that I've gotten really excited about called set reconciliation. It's all about synchronizing databases across a network in really efficient ways so that you don't need to send all of the data back and forth. You can just send differences. I've got a little white paper about invertible Bloom lookup tables. I'm actually, as soon as Patrick stops interrupting me and dragging me to events, I will I will actually get back to working on invertible Bloom lookup tables so that we can have incredibly efficient communication between nodes, and so that every transaction does not have to be sent over the network twice, and we should get a factor of 2 for the amount that we can scale. There have also been a ton of crypto results since 2009 that Satoshi could not have known about because they did not exist yet. So fully homomorphic encryption is really interesting. It's basically being able to store encrypted data up in the cloud and then perform operations on it in such a way that the person who's storing the data has no clue what the data is, even though they're performing useful operations on it. In the context of Bitcoin, this is exciting because, again, if you can validate without knowing anything about what you're validating, that's great for privacy, right? There's related work in non-interactive zero-knowledge proofs, which I got busted. I gave this talk at the Financial Crypto Conference, and I said that non-interactive zero-knowledge proofs were not known in 2009, and a professor raised his hand and said, "You're wrong! Back in 1992, we had anyway. We have practical non-interactive zero-knowledge proofs these days that don't actually take, like a year of CPU time to do. We have these things called snarks, which I don't actually understand. And we don't actually have Smurfs. I just wanted to put a cute picture on my slide. Smurfs are not a thing yet in the crypto world. Yet. I'm sure probably next year there'll be a paper at Financial Crypto, Smurfs for something. So I thought I'd end this talk by talking about what I don't know and what I think is interesting, thinking about how things will go. Will the pseudonymous identity/reputation system be solved? Patrick mentioned identity. I think a lot of problems in the Bitcoin space are problems of identity. Who are you dealing with? Are they trustworthy? Are they running a long con and they'll just run away with everybody's Bitcoins? Are they the CIA with some honeypot website where people can hire people to kill other people, supposedly? All that kind of stuff, right? Those are hard problems. I don't know if they'll be solved or how they'll be solved. The privacy problem, I get bashed a little bit because I say that Bitcoin privacy is complicated. And I think Bitcoin privacy is really complicated. I think it's a hard problem. There's kind of an arms race going on between researchers who try to crack Bitcoin privacy in various ways and researchers who try to improve Bitcoin privacy in various ways. I don't know where that will end up. My best guess is that eventually kind of small, ordinary, everyday Bitcoin transactions will be pretty darn private. Really big transactions will probably be not so private. But I don't know. We'll see. We'll have to see where all of these ideas on improving Bitcoin privacy ends up versus all of the new creative ways researchers have of kind of figuring out what's going on the network. There's a whole area of computer science research about probabilistic algorithms that get the right answer most of the time, but they don't always get the right answer. And that sounds kind of crazy, right? You typically want your computer to give you the right answer all the time. But if the algorithm's a whole lot faster or uses a whole lot less memory, then a probabilistic algorithm can actually work really well. I have a feeling probabilistic mining might be a really good idea. If you can make your miner a whole lot faster by producing hashes that are sometimes, maybe they're not quite right. But they're right often enough, and it's quick enough to check, that might be a really useful thing. I'm thinking probabilistically validating transactions might also be a useful idea as we scale up. We don't need it yet, but I think it's a kind of a good thing to have in our bag of tricks. And then there's another area of computer science research that I haven't even looked at, which are streaming algorithms where you have a fire hose of data coming at you and you can't store it all. So instead, you have these clever algorithms that just deal with it as the stream comes in. I have a feeling that there may be some problems in Bitcoin where streaming algorithms might be really useful. I just don't know where those are yet, but I'll be watching.